For centuries, one archaeological site has quietly challenged nearly everything we think we know about the ancient world. High on the windswept plateau of western Bolivia, nearly 4,000 meters above sea level, lies a collection of shattered stone blocks unlike any found elsewhere on Earth. At first glance, the ruins appear to be little more than the remains of a collapsed monument. Massive slabs of volcanic rock lie scattered across the landscape as though some unimaginable force had ripped apart an enormous structure and tossed its pieces across the plain. But the longer you look, the stranger it becomes. These aren't rough stones shaped by nature. They display astonishingly straight edges, perfectly carved right angles, razor-sharp internal corners, and smooth surfaces that seem almost impossible to have been produced thousands of years ago. Many appear so precisely finished that they resemble components manufactured in a modern industrial workshop rather than blocks carved by ancient craftsmen. Some of the stones feature identical H-shaped designs, repeated with extraordinary consistency. Others contain grooves, sockets, drilled holes, and channels cut so accurately that engineers continue debating how they were ever produced. For generations, archaeologists have walked among these ruins searching for answers. Instead, every discovery has only created more questions. No matter which theory researchers proposed, one stubborn reality remained unchanged. The stones refused to cooperate. Then, something happened that nobody expected. Instead of launching another traditional excavation or proposing yet another historical theory, a team of researchers chose a completely different approach. Rather than asking people to interpret Puma Punku, they asked artificial intelligence, not to confirm anyone's beliefs, not to defend existing academic opinions, and certainly not to support the countless fringe theories that have surrounded this mysterious site for decades. Instead, they gave the system a single instruction: ignore every conclusion that humans have reached. Look only at the evidence. Search every available measurement. Compare every photograph. Study every laser scan. Analyze every excavation record. Treat the entire archaeological site as raw data and identify whatever patterns naturally emerge. It was an experiment unlike anything previously attempted in archaeology. Thousands of individual surveys carried out over more than a century were digitized. Historical sketches made by early explorers, modern drone imagery, laser mapping accurate down to fractions of a millimeter, three-dimensional models of every surviving block, satellite measurements, old excavation notes, even photographs taken decades apart were combined into one enormous digital archive. For the first time in history, nearly every piece of recorded information about Puma Punku could be examined simultaneously. A human researcher simply cannot do that. Even the most dedicated archaeologist spends a lifetime reading reports, comparing measurements, and forming theories one document at a time. No individual can mentally process hundreds of years of observations all at once. A machine can. It doesn't become tired. It doesn't develop emotional attachments to establish theories. It has no professional reputation to defend. It doesn't care whether the conclusions support conventional archaeology or completely overturn it. It only searches for patterns, and almost immediately, the system noticed something that generations of experts had overlooked. Not because it was hidden, but because nobody had ever thought to examine the ruins in quite the same way. Before we reveal what the AI actually found, it's worth understanding why Puma Punku has fascinated researchers for so long. The site forms part of the much larger Tiwanaku ceremonial complex, one of South America's greatest archaeological treasures. Most mainstream historians attribute its construction to the Tiwanaku civilization, a sophisticated culture that flourished long before the rise of the Inca Empire. Exactly when Puma Punku was built remains an active subject of debate. Most archaeological evidence places its construction roughly 1,500 years ago, while some alternative researchers argue that parts of the site could be considerably older. Whatever its true age may be, everyone agrees on one point: the builders achieved something extraordinary. Some individual stone blocks weigh well over 100 tons. These weren't carved from nearby outcrops. Several originated from quarries located many kilometers away across rugged mountain terrain. Transporting such enormous stones would challenge even modern construction crews equipped with cranes, heavy trucks, hydraulic systems, and carefully engineered roads. Yet the builders of Puma Punku supposedly accomplished this without iron tools, without wheels being used for heavy transport, without draft animals capable of pulling such immense loads. Without modern machinery of any kind. How? That single question has frustrated historians for decades. Moving the stones is only the beginning. Shaping them presents an even greater mystery. Many blocks consist of andesite, an exceptionally hard volcanic rock that quickly destroys softer cutting tools. Creating perfectly flat faces in this material is already difficult. Producing identical geometric designs repeatedly is something else entirely. Some interior corners appear so sharp that even experienced machinists have commented on how difficult they would be to reproduce today without precision equipment. The drilled holes display remarkable consistency. Channels remain perfectly aligned. Parallel surfaces maintain astonishing accuracy over surprisingly long distances. Instead of looking handcrafted, many features appear almost standardized, as though they were manufactured according to exact specifications. Naturally, numerous explanations have been proposed. Perhaps ancient craftsmen possessed remarkable patience. Perhaps they relied upon sophisticated abrasive techniques now forgotten. Perhaps they used carefully constructed templates that ensured every cut remained consistent. Each possibility explains part of the puzzle. None explains everything. And that was precisely where the AI entered the story. Human researchers had spent decades focusing on one question: how were these stones made? The machine ignored that question entirely. Instead, it asked something much more fundamental. What if we've been studying the wrong thing all along? That single shift in perspective would become the first step toward one of the most surprising archaeological investigations ever attempted. Because according to the computer, the greatest mystery of Puma Punku wasn't hidden within the giant stones themselves. It was hidden in the spaces between them. And once that realization appeared, the entire site began telling a very different story. The AI's first breakthrough wasn't hidden inside the massive stone blocks. It was hidden in the empty spaces separating them. For generations, archaeologists naturally focused on the monuments themselves, the towering slabs, the famous H-shaped blocks, and the astonishing precision of their carved surfaces captured nearly everyone's attention. But the machine ignored what humans considered important. Instead, it measured every gap, every drilled socket, every recessed groove, and every tiny notch carved into the stone. To the AI, empty space was just as valuable as solid rock. One by one, it compared thousands of individual measurements collected over decades, distances between holes, intervals separating carved channels, the positioning of joints across blocks that now lay scattered throughout the site. Almost immediately, a pattern emerged. The measurements weren't random. Even blocks discovered hundreds of meters apart appeared to follow the same geometric relationships. Certain distances repeated again and again with remarkable consistency, far too often to be dismissed as coincidence. That finding raised an entirely new question. What if these weren't merely decorative carvings? What if every notch, every drilled hole, and every carefully measured gap served a much greater purpose? While researchers debated cutting techniques for decades, the AI reached a different conclusion. It suggested that the builders weren't simply shaping stone, they were encoding information. This idea transformed the entire investigation. Instead of treating Puma Punku as a collection of impressive ruins, the system began examining it like a giant mathematical puzzle. Every measurement became a possible clue. Every repeated dimension hinted at deliberate planning rather than artistic preference. The more data it analyzed, the stronger the pattern became. The identical spacing appeared across multiple stones, even though many of those blocks had been displaced long ago after centuries of earthquakes, weathering, and human activity. That consistency suggested something remarkable. These stones had almost certainly been designed as parts of a much larger, carefully organized structure before it collapsed. Rather than isolated works of craftsmanship, they appeared to function like components in an enormous architectural system, each manufactured according to the same precise set of measurements. Suddenly, the famous H blocks looked less like decorative monuments and more like standardized building elements, almost like pieces of an enormous three-dimensional puzzle. For the first time, researchers began wondering whether Puma Punku had been engineered according to a hidden mathematical blueprint, one that remained invisible until every surviving fragment could be analyzed together. And this was only the beginning, because once the AI recognized that the builders were following strict numerical patterns, it stopped asking how the stones had been carved. Instead, it asked a far more profound question. What exactly were those numbers designed to represent? That single question would soon lead the investigation away from architecture and toward the sky itself. The moment the AI stopped viewing Puma Punku as a construction project, everything changed. Instead of searching for evidence of ancient engineering, it began looking for evidence of ancient mathematics. Every repeated measurement was compared against hundreds of known natural cycles, from the movement of the sun and moon to planetary orbits and seasonal changes. At first, nothing unusual appeared. Many of the patterns seemed too subtle to mean anything on their own. But as the system continued comparing thousands of measurements, one particular sequence refused to disappear. It kept matching a celestial rhythm. Not the yearly journey of the sun, not the familiar phases of the moon, but a far longer cycle, one so gradual that it unfolds over nearly 19 years. Most people have never heard of it. The moon doesn't always rise and set in exactly the same place on the horizon. Over time, those positions slowly shift, reaching their widest point before gradually moving inward again. Completing that entire cycle takes about 18.6 years, a phenomenon known today as the lunar nodal cycle. Recognizing this pattern isn't easy. You can't discover it by watching the sky for a few weeks or even a single year. It requires careful observations passed down across decades. One generation begins the record, while another finishes it. According to the AI's analysis, several of Puma Punku's recurring measurements closely followed this long lunar rhythm. If that interpretation is correct, the implications are extraordinary. It would mean the builders weren't simply constructing ceremonial monuments. They were preserving astronomical knowledge that required nearly 2 decades of continuous observation to understand. In other words, this wasn't knowledge belonging to one individual. It belonged to an entire civilization. a society disciplined enough to maintain precise records across generations. To test the idea, independent astronomers examined the numerical relationships without first being told where they came from. Rather than asking whether the ruins contained hidden meanings, they were simply asked whether the measurements resembled any known astronomical cycle. The answer surprised even the skeptics. While not every measurement aligned perfectly, enough corresponded with the lunar cycle to justify much closer investigation. The resemblance was difficult to dismiss outright. That doesn't prove Puma Punku functioned as an astronomical observatory, but it does raise an important possibility. Perhaps the carvings weren't merely decorative after all. Perhaps some of them acted as permanent reference points, stone markers preserving knowledge that otherwise would have been lost as generations came and went. For centuries, researchers admired the incredible craftsmanship of Puma Punku. Now, the AI suggested that the greatest achievement wasn't the carving itself. It was the information hidden inside those measurements. And if the builders intentionally encoded the movements of the heavens into stone, what other knowledge might still be waiting to be uncovered? Because the machine had only examined the site's geometry. It hadn't yet asked what happened when those stones interacted with something far less obvious than light: sound. The AI had already uncovered evidence suggesting that the builders of Puma Punku understood long-term astronomical cycles. But another question remained unanswered. If these people possessed such sophisticated knowledge of the heavens, why was it carved into stone? To explore that mystery, researchers shifted their attention away from astronomy and toward the architecture itself. This time, they weren't interested in the block's weight or their remarkable precision. They wanted to understand how the structures interacted with sound. Using high-resolution 3D models, engineers recreated the original geometry of surviving walls, doorways, channels, and recessed chambers inside a computer simulation. Every angle and cavity was digitally restored to determine how sound waves would behave if the complex were still standing. The results were unexpected. Instead of scattering randomly, certain low-frequency sounds appeared to concentrate within specific areas of the site. The shapes carved into many of the famous H blocks seemed particularly effective at reinforcing narrow bands of deep vibration. These weren't the high-pitched echoes people usually associate with ancient temples. They were low, powerful frequencies, sounds felt more than heard. Modern scientists refer to these as low-frequency resonances. Under the right conditions, such vibrations can subtly influence how people perceive a space, creating sensations of awe, tension, or even an unusual feeling of presence. Today, architects carefully study these effects when designing concert halls, theaters, and meditation spaces. The possibility that ancient builders may have unintentionally or deliberately created similar acoustic environments is both fascinating and controversial. To verify the computer model, acoustic engineers independently analyzed the digital reconstruction. Their conclusion wasn't that Puma Punku was a giant musical instrument. Rather, they noted that several architectural features appeared unusually efficient at reflecting and sustaining low-frequency sound. The proportions of certain chambers seemed too consistent to dismiss as pure coincidence. Whether this was intentional remains impossible to prove, but the discovery added another layer to an already extraordinary site. Imagine standing within the completed complex thousands of years ago. Priests chanting, ceremonial drums echoing across the stone, wind rushing through carefully aligned openings. The architecture itself may have amplified those sounds, surrounding participants with vibrations that transformed the entire experience. If so, Puma Punku wasn't simply built to be seen. It was designed to be experienced. The sky above, the earth below, and perhaps even the human body itself working together as part of a single ceremonial landscape. By now, the AI had revealed possible connections between mathematics, astronomy, and acoustics, yet one mystery remained. Why had the builders chosen this particular volcanic stone in the first place? The answer, according to the next phase of the investigation, would force researchers to reconsider something they had always taken for granted. Perhaps the stone itself was never chosen by accident. The deeper the investigation went, the more one question refused to go away. If the builders of Puma Punku possessed such remarkable precision, why did they choose this particular type of stone? For decades, most researchers assumed the answer was simple. They used whatever material happened to be available nearby. After all, transporting enormous blocks across the harsh altiplano would have required an extraordinary amount of labor. Logic suggested that ancient builders would naturally select the closest suitable rock. But when the AI compared geological surveys with the chemical composition of Puma Punku's stones, that assumption became less certain. Not every block came from the nearest quarry. In fact, some of the finest andesite appears to have been transported from significantly greater distances than other available sources. That raised an obvious question: why go farther when similar stone existed much closer? To investigate, geologists examined the physical properties of the rock itself, not just its appearance, but its density, mineral composition, and structural consistency. They discovered that the andesite used in many of Puma Punku's precision blocks was exceptionally uniform. Unlike softer sedimentary rock, it fractures predictably, resists erosion, and maintains sharp edges for thousands of years. For builders hoping to create perfectly fitted joints, it was an excellent choice. But there was another intriguing characteristic. Dense volcanic rock also carries vibration differently than softer materials. Engineers have long known that certain rocks transmit mechanical energy more efficiently than others. While that doesn't mean the ancient builders understood the physics involved in modern scientific terms, it does suggest they may have recognized these qualities through centuries of practical experience. A skilled stoneworker doesn't need laboratory equipment to notice which materials crack cleanly, which hold their shape, and which produce different sounds when struck. Knowledge like that can be passed from one generation to the next. It doesn't require modern science, only careful observation. The AI wasn't claiming that Puma Punku was some forgotten high-tech machine. Instead, it pointed towards something arguably even more impressive. A civilization that had spent centuries refining its understanding of stone, learning which materials performed best, which quarries produced the highest quality blocks, which pieces were worth transporting across difficult terrain despite the enormous effort required. In other words, their decisions may not have been mysterious at all. They may have been the result of accumulated expertise. But then the AI uncovered one final pattern that no one expected. When it ranked every surviving stone according to manufacturing precision, something strange emerged. The oldest blocks appeared to be the most accurate. Later editions showed noticeably less precision. Instead of craftsmanship improving over time, as normally happens in every developing civilization, it seemed to decline. The earliest builders produced the finest work. Those who came after struggled to match it. If that pattern is genuine, it suggests the master builders of Puma Punku weren't inventing their techniques. They may have been preserving knowledge that was already beginning to disappear. And that possibility would completely change the story of the site. The AI's final observation may prove to be its most thought-provoking. After analyzing every measurable surface, every joint, and every precision-cut edge, It revealed an unexpected trend. The craftsmanship at Puma Punku didn't appear to improve with time. It seemed to move in the opposite direction. The oldest surviving sections displayed the highest degree of accuracy. Their joints aligned more precisely. Their angles were cleaner. Their dimensions remained remarkably consistent. Later construction phases, however, showed subtle but measurable differences. The cuts became less exact. The joints drifted slightly. Some blocks appeared to imitate earlier designs without achieving the same extraordinary level of precision. This is not the pattern archaeologists normally expect. In most civilizations, technology advances gradually. Builders refine their techniques through experience, passing improved methods from one generation to the next. Cathedrals, pyramids, and monumental cities often demonstrate increasing sophistication as knowledge accumulates. Puma Punku may tell a different story. If the AI's interpretation is correct, the site's greatest craftsmen may have belonged to its earliest generation, while those who followed struggled to preserve techniques they no longer fully understood. That doesn't necessarily point to a lost super-civilization, nor does it prove the existence of forgotten technology. Instead, it reminds us of something history has demonstrated many times before. Knowledge can disappear. Wars destroy libraries. Natural disasters erase entire cities. Empires collapse. Master craftsmen die without passing on their skills. Entire industries vanish, leaving behind only fragments of what once existed. Perhaps Puma Punku represents one of those moments, a place where extraordinary engineering survived just long enough to leave its mark in stone before slowly fading into history. Today, artificial intelligence has given researchers an entirely new way to study ancient civilizations. Rather than replacing archaeologists, it allows them to examine enormous collections of data in ways no human mind could ever accomplish alone. Patterns that once remained hidden across thousands of measurements can now emerge in a matter of hours. Old assumptions can be tested with fresh eyes, or perhaps with no eyes at all. Yet despite all this technology, one truth remains unchanged. Puma Punku has not surrendered all of its secrets. The stones are still there, silent, weathered by centuries of wind and sun, waiting for the next generation of researchers to ask better questions. Perhaps the greatest lesson isn't that ancient people possessed impossible technology. Perhaps it's that we've underestimated what determined human beings can accomplish through patience, observation, and generations of accumulated knowledge. The mystery isn't over. In many ways, it's only just beginning. If you enjoyed this investigation into one of archaeology's greatest enigmas, make sure to subscribe and turn on notifications because we're exploring many more ancient mysteries where science, history, and cutting-edge technology collide. And now we want to hear from you. Do you believe Puma Punku represents the achievements of an incredibly skilled ancient civilization using techniques we've simply forgotten? Or do you think there's still something much bigger hiding beneath the surface of this remarkable site? Share your thoughts in the comments below. Thanks for watching, and we'll see you in the next investigation.